Okay, good day, grade 8s. We're going to try this again. We're going to re-record this video. This time I'm going to break it up into 3 parts. I think part of the issue from the previous video is that being over an hour long, it was tough for the YouTube or even my desktop computer to process. So bottom line is we're going to do this in 3 parts. So let's just begin again with lesson 6. This is on page 34. Okay. That's a 3 there. So Gerald spent $205.60 at Walmart. The sales tax is 5%. What was his final bill? Now, just a little thing here. It says recall. So lesson 5 dealt with like one-step problems, and lesson 6, where it says application of percent part 2, there's going to be more than one step. So the problems are a little bit more complex. But let's begin with this one. That is fairly straightforward. 5%. You're going to ask yourself, what's the percent of a number? 5% of $205.60. Now, I told you to translate these. So you have $205.60. Okay, of means times, and 5% is 0.05. Okay, so just remember, down here, what does 5% mean? It means that you can ditch the subtraction sign and instead put it over 100. Just rewrite it. And when you take 5 divided by 100, okay, just doing a quick review here, divided by 100, okay, you get 0.05. That's where this, this whole idea of moving the decimal place 2 places to the left, that's what happens. If there's 2 zeros, right, on a power of 10, move it 2 places to the right. Okay, let's finish the question. 0.05 times 205.6. Okay, so that's $10.28. Okay, so what do we do with that? Like, what did we just find out? Okay, this is the tax only. Okay, so at the end, at the very end, you're going to have to add this up. So $205.60 plus $10.28. What's Gerald's spending in the end? Well, 8,512. Don't forget your concluding sentence. Okay, so Gerald spent a total of $215.88, including tax. Okay, we're just abbreviating including tax. Okay? So that's how you do that question. Make sure you write your concluding sentence. Okay, we're at page 35 now. Let's deal with the second example. The only real difference here, grade 8s, is that you've got 2 taxes. So not a big deal, okay? One of the things you can do with taxes, because they're calculated essentially at the same time and on the same amount, right? There's no discount to deal with here or any other calculations. This price is not changing. So you can add your total tax right at the beginning and just say, look, I'm going to take the GST, okay, plus the PST, and I'm going to treat that as if it were, what's 5 plus 7, as if it were a 12% total tax. And you can do that, okay? So what is the total cost of an item that costs $43 if the GST is 5% and the PST is 7%? Well, you're still doing just percent of a number, okay? That's the essence of virtually all these questions, whether they're 1-step or 2-step. It's doing percent of a number. Percent of a number, whether it's discount, sales, taxes, commission, whatever it is, you're setting up the same percent of a number. Okay, so in this case, we got 12% of $43. Okay, this is 0.12 as a decimal. This is times. Don't do anything to this number. Okay. So let's see what that works out to be. 0.12 times 43. Okay, here we're paying $5.16 of tax. Okay, we just calculated the tax only. Let's add that up. Okay, so the final price. Okay, how much is this person actually paying when they get to the till? Okay, they've got $43, $5.16, $48.16. Okay, don't forget your sentence. The total cost is $48.16. Okay? Okay, now before I finish this, I do want to show you this alternate way, all right? There's another way of thinking about this. When I was mentioning this in class, $43 represents 100% of the price, okay? You're paying the $43. Now, when you add the tax, isn't it proper to say in the end, okay, in the end, your final price, right? Your final price is essentially 112%. Okay? You're going to end up paying 112% of $43. Let's see what that looks like. 112% of 43. Okay, so that's 1.12 times 43. Let's just see what that gives us. So 1.12 times 43. $48.16, okay? Now, should you be surprised by this, the fact that it gets the same answer? No, because all we're doing is we're kind of baking together, like we're embedding, we're combining the fact that we're going to pay 100%. 100% is represented by 1.00, but we're not going to leave it at 00. We're going to add the 12%. So this is sort of the final all-in total price baked together, rather than, it saves us the step of actually having to add this up at the end, okay? Okay, so the final price here is $48.16. You would write the same total cost. Let's move on to the next question. If there is a 30% off sale on an item that costs $89.90, what is the sale price, okay? If there's a 30% off sale, $89, what is the sale price? Okay, so again, let's do percent of a number. 30% of which number? 89.90. Okay, 0.30 times. Okay, I'm going to stop drawing the arrows because I think at this point most of you, if not all of you, are getting it. So let's do this. Okay, what is 0.3 times 89.9? That's equal to, let's just put it over here. Okay, $26.97. What does that represent? $26.97. Okay, like what did we just calculate? What's the meaning of this number? Well, this number is 30% of $89.90. This is going to be the savings this is the amount of money you savings, or sometimes we call it, this is the discount. Okay, so the sale price then, okay, is take your regular price. But what are we going to do? Add or subtract? We're going to subtract. Okay, we're saving money here. There's Mr. Smith's good old phone reminding him to do stuff. Okay, so $89.90 minus $26.97. Okay, so the sale price is $62.93. $62.93. Okay, now look, this is the sales price. It's not the final price. This question didn't talk about taxes. It doesn't talk about what you're going to finally pay at the till. It doesn't mention taxes. So right now, we're content to find out this is the sales price. Okay, this is the sales price. Okay, the sales price is $62.93. Okay? Okay, now there's a challenge here. It says, could you solve the question using one step? Okay? So what it's saying to you is, first you found a percent of a number, so this was essentially step one, and then step two required you to subtract that number. And that's no big deal. It's two steps. I would argue they're fairly straightforward. They don't take up too much time. But in a similar thinking process, okay, the questions are not the same, because this deals with tax and this deals with savings, but in a similar way of mathematically thinking, is there a shortcut available? Okay, and yes, there is. All right, there is. So what I would challenge you to do is think in reverse. Okay, think in reverse. Just going to highlight that. Think in reverse. Okay, so in other words, if the discount, well, that's supposed to be the word the, if the discount, okay, if the discount equals 30%, then the sales price should be what's left. I'm going to highlight that. What's left over. I want you to think of this, try and think of this in percentages. Okay, the regular price was $89.90. That is represented by 100%. Like without the sale, if the sale didn't exist, you'd be going to the store and paying 100% of the regular price. Now the discount, okay, which we calculated in the previous example, happened to be $26.97, okay, and that was represented by taking away, so let's put a subtraction sign there, we took away 30% of the price. So you can think of it like the leftover price, which should be, reduced, the sales price, the leftover, I'm going to put that in quotes, the leftover price, in other words, that's what IE means. In other words, the sales price, think of it from a percentage point of view. Isn't 100% minus 30% equal to 70%? So if we're asked to find the discount, right, then you would take 30% and find that. And by the way, this question actually didn't ask for the discount. It actually asked for the final sale price. So it makes sense that the challenge, don't know what's going on here, it makes sense that the challenge would ask, can you do this in one step? Yeah, 70%, okay? So let's find 70% of a number. Okay, so let's 0.70 times 89.90. Now, watch the magic here, grade 8s. Watch the magic. 0.7 times, let's put it up here so we can watch this. 0.7 times 89.90. Look at that. Same answer. So look, in the calculator we could do it one step. First we did 30% of a number, then we subtracted it. But you could also say, instead of taking 30%, why don't we just do 70% of the original price? The sales price is the fractional or percent amount remaining. 70% of this, that's what 0.7 is, it's 70%. So both methods will work, okay? So this is 62.93. Okay, I hope that made sense. Okay, so we're going to carry on with page 36, and then I think this will be the end of part 1. I don't want to risk going on too long because, like I said, due to the issues we had yesterday, I don't want to risk that today. So a city has a population of 23,508 and the population decreases by 3.5%. What does decrease suggest to you? Well, in my mind, that suggests some sort of subtraction thing going on. Regardless, like the basic setup applies for all of these questions, okay? It's not to say that, some of the questions might change it up a little bit, but the basic setup applies. That means, to put it in words, percent, okay, of a number. Okay, just write it out like that. And then what happens is you end up ignoring the letter or the word a. So percent of number. Okay, so think about it. Look at this question and just see the numbers that are given to you. You know it's going to be decreasing, so that's probably a subtraction at some point. So this time it's 3.5% of what? 23,508. Okay, now we'll translate, all right? So just remember, what is 3.5%? 3.5% is 3.5. Don't touch this number. I see too many students who think they have to move the decimal at this point. Not necessarily. If you're just going to ditch the subtraction sign, okay, and then just replace that with over 100, and if you actually do the division, that's when the decimal moves. But don't move the decimal and write it over 100. That makes absolutely no sense. Okay, so 3.5 divided by 100. Okay, 0.035. Okay, so that's equal to 0.035. Okay, not 0.35 and not 0.0035. Okay, you do have to get your decimals correct. If you're going to bounce the decimal, right, from here, you would go, just grab a pencil here, and I'll just do it over here, 3.5%. Okay, if you're going to bounce the decimal once, twice, as soon as you get a gap, you fill it in with the 0, your decimal lands there. If you want, you can. Some students feel better putting the 0 in front, so 0.035. But then don't go put it over 100 now. You've already done the dividing by 100, okay? So if you learn to bounce, then bounce. It's always 2 decimal places to the left when you're going from percentage to decimal, okay? Bounce left, 2 places, okay? 1, 2. All right, carrying on. 23,508. And what does that equal to? I'll put it over here. The light is a little bit better. So times 23,508. 822.78. Now, a quick heads up. Do not round this up. I know the regular rounding rules suggest that you should round up. The regular rounding rules do not apply. Remember, you can't have a fractional person. And since this isn't 800, like it's either 823 or 822, but when you're talking about real life situations, you go to the last whole person. The last whole person on this calculation of this multiplication is 822. You might as well just cover this up. Just cover up the decimal because it's irrelevant. So it's 822 persons. Okay, so it's equal to 822 persons. Now, okay, so you got to add. You got to decide: is it add or is it subtract? Is it add or subtract? Well, go back. Look at this word. So to my mind, it makes sense to take 23,508 and subtract 822 people. That's what happens. The population decreased. Okay, so let's just clear the space here on the calculator. Put it more in the light here. 23,508 minus 822. 22,686. 22,686. Okay, don't forget your sentence. The city's new population, I'm just going to abbreviate that, is 22,686. Okay? Okay, a store is having a big sale. Everything is 30% off. Everything is 30% off, but for one day only, an extra 40% will be taken off the discounted prices. So what is the sale price of an item that costs $100? Would a 70% off sale result in the same price? Well, we covered this in class, but let me go through it again. I'm not going to spend a huge amount of time on it because we did go through it, but let's just see what this looks like. We're going to compare. So method 1. Okay, method 1. We're going to take off 30%, then, so like in steps, then we'll take another 40% off. Okay, versus, so we're going to do a versus here. Method 2. Okay, 70% off one time, like right away. Okay, so rather than break it down into steps, let's see what happens here. Okay, so the item is, so the regular price is $100. Okay, the first discount is to take minus 38%. That's equal to minus $30. Okay, sorry, that's a dollar sign. So basically 100 minus 30 is equal to $70. Okay? So that's the first sales price. Now the store decided maybe that wasn't enough a discount to like sell the thing, whatever it is they're selling. So then they kind of do, and I'll just, so I drew that line because that's what happened first. Now the second discount, okay, is minus 40% off the first sales price, off the sales price. Just going to pre-highlight that. Off the sales price, not the regular price, and that's going to end up being the difference. Okay? So, what is 40% of 70? Not 100. That's what's going to make the difference here. Unfortunately, we're not allowed to take 40% off 100 because that would be $40. But if you're taking 40% off a smaller amount, unfortunately that discount wouldn't have been as good as if we took it off the $100. Let's just see what this looks like. So 0.40 times 70, that's equal to $28. See, had we been allowed to take the 40% off the 100, that would have been $40. But yeah, c'est la vie. So the final sales price, I'm going to just put SP, okay? The final sales price is equal to 70 minus 28, and that's equal to $42. Okay. Now compare that to if the regular price starts off the same, it's still the same item, it's $100, and the one and only discount is $70 or 70% off. 70% off. Okay, that does translate to $70. We're subtracting. Okay, so let's just close the gap here. So what is 100 minus 70? That's equal to 30. So the final sales price here, sales price, I'm abbreviating, is equal to $30. So again, we're comparing these two. So really, to add some comments here, so they are different prices. Okay. All right, they're different prices. And we have to ask ourselves maybe why. Well, again, sorry if that's confusing. This is a 0. The difference is the 40% and the 30%, the total of 70% is applied to the $100. Whereas over here, only the 30% applied, only that discount of 30% applied to the $100, then the 40% applied to the 70. So it's the fact that the 40% had to kind of wait until this first sales price. So 70 is less than 100, so this discount would have been is less, like 40% of 70 is 28. That's the precise answer. But 40%, I'll just write it down here, 40% of 100 is $40. You see? So in both cases, it's the same percent, but it's the dollar amount that changed the calculation, right? 40% of $100 is $40. So the difference between 28 and 40 is $12, and that's why this price is $12 more than this one, because the 40% wasn't applied to the 100, the 40% was applied to the 70. That decreases the actual discount that you get and ends up making the final price slightly higher than this one. So whenever you're shopping, like, you want the biggest discount up front right away, no questions asked. Okay, this is going to be the end of part 1.